With everyone? Is 26 okay?
Yeah, it looks good.
It's not a friendly function. The reason I'm saying that is also the fact that I have to find its domain. And the domain is not friendly. For a square root function of this kind, now if you give me the square root of x, I'll say, oh, no problem, domain 0 to infinity, done. But here I have to write that 2 minus x squared must be greater than or equal to 0, which has a long story, because this is a quadratic inequality. How do I solve a quadratic inequality? First of all, I have to arrange it in the correct order. Of course, I avoid a negative linear coefficient at any cost, at all costs. X squared minus 2 less than or equal to 0. And I know the solutions, I know we never really think in terms of factoring 2, right? This is very easy, x plus 2, x minus 2. But it's easier if you think in the same terms and you write this. It will save us some time. And now I have to find the interval. So if you graph this, that's one other way. I don't really like doing, because this could be very difficult and it will take me a while to graph. But because this is quadratic and it crosses at negative the square root of 2 and the square root of 2 and it looks like this, then I know that it's between negative the square root of 2 and the square root of 2. The other option is to study the sign of the product. So I know that this is negative and outside is positive. So I want the negative piece. So the domain of this function is negative the square root of 2, the square root of 2, and nothing else. Anything else that you want to plug in the function, the square root will be imaginary. So that's why these functions are not very friendly. Negative the square root of 2, the square root of 2. Next step. I have to plug in 0. And when I plug in 0, this is 0 times whatever, that will be 0. And I have to plug in the endpoints, but when this is the square root of 2 or negative the square root of 2, it doesn't matter, this will be 0. So this is also 0, and this is 0. There is nothing else. I'm done with the function. So now I continue with the derivative. So y prime, it's a product. First function, prime is 1. The square root of 2 minus x squared plus x multiplied by 1 over 2 the square root of 2 minus x squared multiplied by negative 2x. So the 2's will go away. So then y prime is the square root of 2 minus x squared, but minus x squared over the square root of 2 minus x squared. Now you have to realize that it's absolutely mandatory to find the least common denominator. Like I was hoping you would do that on the last test. So what is the least common denominator? There is only one, so there is no discussion there, right? So this needs to be multiplied by the square root of 2 minus x squared. Can anyone give us the numerator?
Is it going to be 2 minus x squared minus x squared?
Perfect. Great job. Thank you, Mark. Minus 2 minus x squared. the square root of 2 minus x squared. Yes, you know me. So this is x squared minus 1 over the square root of 2 minus x squared. So this is negative 2, x plus 1, x minus 1, the square root of 2 minus x squared. Okay, back to my table. So f prime can be 0, f prime can be undefined. Where is f prime 0? Will you tell us where is f prime 0?
F prime is 0, correct?
Look at the function.
Yeah, 0.
It's going to be 1 and negative 1.
Very good. The numerator is 0 at 1 and negative 1.
0.
And where is this function undefined? So this is x equals 1, x equals negative 1. The numerator is 0. And where is this function undefined? So this function is defined at the square root of 2 plus or minus the square root of 2. But this one is not, because it has a denominator. So it's undefined at x equals plus or minus the square root of 2. So that's why I have to put a bar here and here. A bar here, undefined, undefined. And now I have to study the sign here, here, and here. So let's see what I will not use for studying the sign. Of course not this. It's always positive. I'm not going to waste my time. So now when I plug in 0, negative 2 times negative 1 will be positive. And when I plug in negative 1.1, negative 1.1, this is negative, negative, negative. With 1.1, 1.1, positive, positive, negative. I have to find this number, the value of the function at negative 1 and the value of the function at 1. So look at this. It's an odd function, right? So with 1, so this is 1 and 1. And with negative 1 is negative 1. Okay. Moment of truth. I know I will stop after this and we'll continue with the second derivative because I can't finish it in 1 minute. At this moment, I have to check that these two are perfect, in perfect sync. If they're not, something is terribly wrong. Okay, from 0 to negative 1, what does the function do?
Decreases?
Good. Is that supported by the sign of the first derivative?
Yes.
Perfect. Okay, from negative 1 to 0 and to 1, up, up, and it's supported. From negative 1 to 0 to 1, it's indeed increasing. From 1 to 0 is decreasing. What type of point is negative 1, comma negative 1, and what type of point is 1, comma 1?
Local min?
Thank you very much. And local?
Max.
Max. Good. So these will be the endpoints of the interval. We're going to have to study the second derivative, find if there are any inflection points, and then finish it up. So sorry, but